Our solar system is a savage place. From the ice volcanoes of Saturn's moon Enceladus, to the vast lava fields of Jupiter's Io, to our own world, the Earth. Volcanoes destroy. They also create.
It is literally true that if there weren't volcanoes here, we would not be here either.
Volcanoes shape and change our climate.
Volcanoes are the giver of life and also the takers of life.
Today's space probes and telescopes reveal volcanoes on worlds we once thought dead.
Finding volcanoes on an object that's smaller than our own moon was a huge shock.
If volcanoes exist on other worlds, could we find life there too? Planet Earth, a jewel in the darkness of space. Our home is timeless, beautiful, and incredibly violent. Volcanoes are one of the most powerful natural phenomena on the planet. They create new land, destroy the old. They blast out gases that transform the air we breathe. Deep in our oceans, volcanic heat fuels strange new life. Volcanoes help power the living Earth. Now we search for signs of life on alien worlds. We know life needs water. We know it needs energy. And that's where volcanoes come in. They pump out vast amounts of energy. Find volcanoes on other worlds, and we might find life. The search starts here. The planet orbiting closest to Earth, Venus, a world that appears very much like ours.
Venus and Earth are roughly the same mass, they're roughly the same distance away from the sun, so they're kind of like twins.
Three billion years ago, Earth and Venus were very similar. New land, new oceans, an atmosphere. Both planets were perfect for life. But on Venus, something went wrong.
Something made Venus diverge radically from the history of the Earth.
Venus took a definite turn to the dark side a long time ago.
Venus is a hellhole, our evil twin.
Today, Venus's surface is like a furnace.
It's 900 degrees Fahrenheit on the surface, and it's hot enough to melt actually some metals, so you wouldn't stand a chance.
Venus is a greenhouse world. Its atmosphere is thick with carbon dioxide. It traps heat from the sun like a blanket. These actual images of Venus's surface reveal a barren, superheated wasteland. Venus's thick blanket of CO2 killed the planet. The CO2 came from volcanoes. Orbiting space probes gave the first clues. Radar punched through Venus's thick clouds and revealed volcanic formations across the planet. like formations we also see right here on Earth. The shield volcanoes of Hawaii. Shield volcanoes get their name from their round, flat shape. These volcanoes ooze, but they ooze for thousands of years.
Once we were able to map the entire surface of Venus using cloud-penetrating radar, we started to study the landforms there, and we saw a lot that was actually very familiar. In particular, we saw giant shield volcanoes that are very similar to the shield volcanoes here in Hawaii.
The radar images of Venus were dead ringers for the shield volcanoes on Hawaii. Sometime in the past, Venus had volcanoes.
For the first time, we had a picture of Venus revealed. And boy, were we shocked. We found a scarred surface, a volcanic surface.
There are at least 1,000 volcanoes that are very large, and maybe tens or even hundreds of thousands of smaller ones.
3/4 of Venus's surface is lava plains, evidence of an ancient cataclysm. This could have been a home for life. Instead, it was engulfed by fire. Volcanoes belched trillions of tons of carbon dioxide into Venus's atmosphere. Temperatures soared. The seas boiled dry. A runaway greenhouse process began.
On Earth, carbon dioxide is able to absorb into the rocks, it's able to absorb into the ocean. But on Venus, you have no water, and it's now so hot that carbon dioxide can't even combine with the rocks. So as carbon dioxide was released into the atmosphere by volcanoes a long time ago, over time there was less and less of a method to take it back out of the atmosphere.
If Venus ever had life, volcanoes sterilize the entire world. Earth remains the only living world we know of. That may change. This is the gas giant Jupiter. Its moons frozen and dead. Or so we thought. Look closer, and a mystery emerges. A cloud hanging over a cold and lifeless world. On Venus, volcanoes turned an Earth-like world into a superheated hell. Finding volcanoes on an Earth-like world was no surprise. But spotting volcanoes on a moon was a shock. In March 1979, the Voyager 1 space probe gave us our first close-up view of Jupiter's tiny moon, Io. A world we once thought cold and dead.
And they saw something really weird. They saw this arc next to the moon. And it looked almost as if like there was another moon behind it.
And we scratched our heads and said, well, what could that be? Everybody knows that Io is dead, boring, uninteresting. And then people realized, oh my God, it's a volcanic eruption.
We found that it's covered with volcanoes. It is tremendously geologically active. There are volcanoes erupting all the time. And what they're erupting is a lot of sulfur, and it gets very hot. And sulfur, when it changes temperature, changes color. It can be red or orange or yellow or black. And so these pictures of the face of Io make it look like a pizza covered with different kinds of cheese and olives where the little black spots are.
Io is not dead. It's alive and kicking. It has over 400 active volcanoes. The largest, Pele, erupts from a gigantic lava lake. It reaches nearly 250 miles into space.
If we could stand on the edge of that lava lake and watch that plume shooting off into the blackness of space, that would be an incredible sight.
Pele's eruptions are so huge because Io is so small. There's nothing to hold the lava back, virtually no atmosphere, and very little gravity. These vast eruptions make Earth volcanoes look like firecrackers. How can such a tiny moon be so volcanic? The answer is Jupiter. Just as the moon raises tides in Earth's oceans, Jupiter raises tides on Io, tides of solid rock. Io's orbit around Jupiter is not a circle. Sometimes it's closer, sometimes farther away. Jupiter gives Io a gravitational pounding.
And so Jupiter's gravity pulls on it a little bit harder and a little bit weaker. And what happens is the moon stretches like this. It's called a tidal force, and it doesn't stretch this much, it's only a little bit. But in fact, it's enough to heat it up.
It's just friction. It's the same way when you rub your hands together really fast, they begin to feel warm. Friction creates heat.
Jupiter's gravity stretches and squeezes Io. In every 2-day orbit, the ground rises and falls by nearly 300 feet. This pummeling generates intense heat and gigantic pressure.
Wherever there's a weak part in the crust, the lava rushes out. So the volcanism is on a planetary scale. Unlike here on Earth, where there are certain bits that are active around the plates or in weak spots, this is an entire moon that's one active hotspot.
Thanks to the incredible power of gravity, Io is the most volcanically active world in the solar system.
The volcanism on Io taught us something new. It taught us that internal sources of energy can drive volcanism in a way that's different from that on Earth.
In outer space, tidal forces, the differential squeezing of the moons of a gas giant, can also create volcanic activity. That was a game changer.
Io is a lava world, superheated and violent. It's hard to imagine anything surviving there. Yet the volcanic principle here is the same as on Earth. Pressurized, superheated magma below the surface blasts through fissures in the crust. But not all volcanoes need magma. They don't even need to be hot. Travel out past Jupiter into the outer solar system, and it gets cold, really cold. The distant moon Triton is so cold that much of its tenuous atmosphere can freeze solid. Yet there are volcanoes here. Volcanoes that may hold the secret of alien life. This is one of the strangest worlds in our solar system, Saturn. A ring system 600,000 miles wide, an amazing 62 moons, and one with a secret.
Enceladus is one of Saturn's smaller, more distant moons, and it's been known for a long time that it's covered in ice because it's very bright, very reflective. But when the Cassini spacecraft went there, it discovered something amazing.
The Cassini probe revealed something incredible. not on the planet itself, but on Enceladus. Backlit by the sun, a gigantic plume bursts out into space, a sure sign of volcanic activity. It was an amazing discovery, and it helped answer a question that has puzzled scientists for decades: the mystery of Saturn's E-ring. Saturn's outermost ring is vast, almost 200,000 miles across, and it shouldn't exist. The ice particles that make up most of the ring are too far from Saturn to stay in orbit. They constantly drift away into space. Something replenishes the ring: the ice volcanoes of Enceladus.
Those plumes that are ejected from Enceladus' south pole, it turns out that those are going into space, and they're not just going away. They're feeding a ring around Saturn, the E-ring. So this little moon is giving something back to its parent planet.
Water blasts from Enceladus's volcanoes, hits the vacuum of space, and instantly freezes into tiny ice crystals, creating the vast E-ring. One mystery solved. Another replaces it. What creates the volcanic plumes? Cassini's cameras zoom in on the moon's south pole and capture these huge chasms scarring the surface.
There are these wonderfully huge cracks at the south pole of Enceladus. And as Enceladus goes around Saturn, these cracks open and shut as the tides go by. Now, these cracks are huge. They're hundreds of miles long. And when they begin to open, you would have this big crevasse opening at maybe 100 miles an hour down the length of that. It'd be incredibly spectacular.
Huge gravitational forces crack the surface open and closed at enormous speeds. Like Europa and Io's orbits round Jupiter, Enceladus's orbit round Saturn is elliptical. This helps generate the heat to melt ice and create oceans of water beneath the surface.
The conditions of the water underneath Enceladus' surface are absolutely perfect for life. It's the right temperature, it'd be a good pressure for life. Liquid water would be just like seawater here on Earth. And the chemistry of the water we see shooting out of these vents suggests that it is very similar. There's salt, there's organic material in it as well. So we have identified a place in the solar system where there very well may be life right now.
Cassini has detected complex carbon molecules in the ice plumes. Combined with liquid water, these suggest that just maybe life could survive deep within this enigmatic moon. Enceladus may not be alone. Another of Saturn's moons might also harbor life: Titan, one of the largest moons in our solar system. The only moon with a thick atmosphere. A frozen world, ice as hard as rock, lakes of liquid methane. Yet here too, we might find evidence of volcanoes and the tantalizing prospect of alien life. A raging inferno on the surface of Io. Eruptions of ice and nitrogen on Triton. Volcanoes are one of the most destructive forces in our universe. out of annihilation comes the possibility of life. Even here, on Saturn's mysterious moon, Titan. It's 3,000 miles across, larger than the planet Mercury. It's the only moon in our solar system with a thick atmosphere. There is weather here, storms, winds, rain, even lakes, all so cold that liquid methane takes the place of water. And it's loaded with chemicals that life needs to survive.
Titan has turned out to be absolutely one of the most interesting places in the solar system. It's an active world. It's the only moon with a thick atmosphere, an atmosphere very much like Earth because it's mostly nitrogen, and it turns out an atmosphere loaded with organic molecules.
Methane gas high in Titan's atmosphere reacts with sunlight and creates the kind of chemicals life depends on. But if sunlight converts methane into organics continuously, why doesn't the methane run out?
The atmosphere is full of methane, and yet we know methane is being destroyed by sunlight on a short time scale, so it shouldn't be there. There needs to be a source of methane.
Something on Titan pumps out a continuous supply of methane. Cassini has detected what looks like a crater. Its interior is as deep as the Grand Canyon. Infrared cameras reveal different types of materials surrounding the crater. Scientists believe the green areas could be volcanic, perhaps plains of lava ejected from Titan's interior. If it exists, lava, Titan style, is a super chilled, icy slush. But compared to the rest of Titan, even ice slush is scalding hot.
On Titan, the hot liquids spewing from volcanoes might be ammonia or water. Normally those are frozen solid on the surface, but if they're heated beneath the surface somehow, they could erupt out.
On Titan, what comes out of volcanoes is methane and ethane. And that's probably the reason why we have this very thick cloud cover, this orange haze around Titan. This haze probably came from outgassing from the volcanoes of Titan.
Even for volcanoes on a world as cold as Titan, you need heat. That's what turns ice into liquid and generates eruptions. On Titan, that heat has two sources. Radioactive materials warm the interior. And Saturn's huge gravity massages the moon, just like Enceladus. These two forces generate enough heat to turn ice into water and liquid methane to gas.
We think of volcanoes as being hot and ice is cold, and yet if you're out on Titan, where you're a billion miles from the sun and it's quite cold, then those flows of just barely above freezing water, ammonia, ice, they might be the hottest things around. So hot is a relative term depending on where in the solar system you are.
Could volcanoes on Titan give life a chance to survive here? Life as we know it needs an atmosphere, a solid surface, liquid water, and the heat to drive chemical reactions. On Titan, volcanoes could provide them all.
If you have a volcano on Titan, you'll have heat added to that. And all of a sudden, you'll have liquid water surrounded by organic material. I mean, literally anything you need for the start of life.
If life does exist on Titan, it would be truly alien. It would breathe hydrogen in place of oxygen, perhaps swimming through lakes of liquid methane at 300 degrees below zero.
Perhaps there are oceans of ethane. Perhaps there are tide pools, and perhaps volcanic activity and hydrothermal activity. Perhaps there are hot springs. Perhaps volcanic heat could generate enough to get life off the ground in Titan. That's a speculation, but it can't be ruled out.
But we may not need to travel this far to find signs of life. We may find it on a volcanic world much closer to home. The red planet, Mars. Volcanoes are everywhere, across the solar system. Worlds like Io, Titan, and Triton are complex, dynamic, and violent. Once, we thought that Earth was the only planet with volcanoes and with life. Now we find volcanoes everywhere, but we have yet to find alien life.
Volcanoes embody the sheer power of creation and destruction, and they go hand in hand. It is literally true that if there weren't volcanoes here, we would not be here either. In the cauldrons of volcanoes is the origin of life.
Volcanoes create new landscapes, seed the atmosphere with complex chemicals, replace the old with the new. If volcanoes are bound up with the processes of life, then where is the life on other worlds? Perhaps the answer originates in deep time when the solar system was young. On a young planet, much like our own. This is Mars. 3 billion years ago, it had active volcanoes. One still remains the largest volcano in the solar system. The cliffs leading to it are over 6 miles high. Mount Everest would sit comfortably in their shadow. And those are just the foothills. This is the awe-inspiring Olympus Mons. It covers an area the size of Arizona. Its crater alone is 53 miles wide. A Goliath like this takes millions of years to build, time that volcanoes here on Earth never get. On Earth, the crust is always moving. Deep below, a single hotspot pushes magma through the surface, building a new volcanic island. But while the hotspot stays still, the surface is moving. The new island moves away from the hotspot, and a new volcanic island takes its place. Mars is different. The crust is locked solid.
On Mars, there's just none of that tectonic activity. The crust is one big solid plate, and so if there's a hot spot, it just sits there and builds and builds and builds, and you get a bigger and bigger and bigger volcano. And that's why Olympus Mons is so huge.
Olympus Mons today is a frozen relic of a distant, warmer past. Mars's shrunken atmosphere means that Olympus now reaches almost into space. A true colossus, an extinct volcano on a dying world. But Mars's ancient volcanic terrain could, one day, harbor life again. The evidence is right here on Earth. On Hawaii, volcanoes have created mysterious tunnels called lava tubes. Channels left behind when torrents of molten rock surge into the sea. But some are now empty, and that offers us an opportunity.
Lava tubes are formed when you have an underground river of hot basaltic lava, 2,000-degree magma, molten rock. And picture it like a frozen river of water with the ice crust forming on the top. It's the same thing, only here the crust is solid rock, and the river keeps flowing underneath and makes this cave, this lava tube.
Extraordinary recent images suggest Mars's volcanoes also may have created lava tubes.
Any planet with basaltic volcanism, any rocky planet, will probably have lava tubes. And now we found a couple of them on Mars, in places where there are skylights, places where the roof has collapsed and you can see from orbit right into those lava tubes.
If some tubes have collapsed, perhaps many others are still intact. The ancient relics of Mars's volcanic past. Now, after lying dormant for perhaps millions of years, these lava tubes could bring life back to the red planet. That life will be us.
One of the challenges of living on Mars for future humans will be the radiation environment, and in particular when there are solar storms, the cosmic rays coming in can be deadly, and having a storm shelter under some large mass of rock is really the best way to protect yourself from cosmic rays.
The tubes and caves of Mars's extinct volcanoes might one day make a perfect home, holding in air, shielding us from deadly radiation. A long-dead volcano could help fill a world with new life. Volcanoes can destroy, but they can also create. From the superheated vents of Europa's 60-mile deep ocean, to the water volcanoes of Titan and the rock volcanoes of Earth, vast geologic processes shape our worlds, our imaginations, and perhaps the very stuff of life.